And now for the answer. Let's check each one by one. When all tests fail, that's an interesting situation. It's rather unlikely, but let's assume this actually happens. Then we split the inputs initially into two subsets. Removing the first subset fails. We proceed with this subset. N remains 2. And we do this again, and we split again the input into two subsets, and two subsets again, and two subsets again. And this is exactly like binary search described by Kernighan and Pike, which is logarithmic. The next answer, when there always is a half that can be removed and fails, this is the same situation except that we may have to remove the first half first and getting a pass. But still, in terms of complexity, it's still logarithmic in proportion to the size of the input, and therefore this is a nice situation in which delta debugging is very, very effective. This is actually one of the strengths of delta debugging, that if you can split the input into two halves and one of them fails, then it behaves like binary search. And by increasing the granularity later on, then it's no longer as efficient in the number of tests, but it's very, very thorough by trying to remove small parts one after the other. So it's like a binary search in the beginning, super efficient, and then it's as thorough as trying to remove every single part after another. When all tests pass, and then delta debugging does not need a logarithmic number of tests. That's more like a linear number of tests. And never, that's not the case, because in these two situations, then indeed the number of tests is logarithmic. So this is the answer.